All right, let's start looking for solutions of differential equations. We're going to start with homogeneous linear differential equations with constant coefficients. Linear differential equation with constant coefficients means that the left-hand side is a linear combination of y and its derivatives. Homogeneous means the right-hand side is 0. So a differential equation of the form nth derivative of y plus a1 n minus first derivative of y, etc. up to a n y equals 0. This is homogeneous constant coefficients because we have numbers next to the derivatives of y and y itself. Has solutions built from functions of the form y equals e to the rx. Where the values of r depend on the coefficients a1 through an. Now to see which values of r, we'll plug in e to the rx for y here, and let's observe that the kth derivative of e to the rx is, well, every time we take a derivative we bring an r down in front, so it's going to be r to the k e to the rx. So that means that if y equals e to the rx is a solution of the homogeneous differential equation, then we have, let's see, nth derivative r to the n e to the rx plus a1 r to the n minus 1 e to the rx plus a2 r to the n minus 2 e to the rx, etc. up to an e to the rx. All of that should be equal to 0. Now we can factor out an e to the rx, and that leaves us with rn plus a1 r to the n minus 1 plus a2 r to the n minus 2 up to an. So this is equal to 0. Now, e to the rx is never 0. So we're really interested in what values of r satisfy this. And the equality of this polynomial with 0 is called the auxiliary equation. We can call this the auxiliary polynomial. And we're going off the screen. The auxiliary polynomial, or the auxiliary equation if we say that polynomial equals 0. So to find out which functions y equals e to the rx, are solutions of the homogeneous differential equation will solve Rn plus a1 r to the n minus 1 plus a2 r to the n minus 2, etc. plus an equals 0 for r. Now there's a couple different things that could happen. This could have n different solutions. So there's 4 possibilities. For solutions. They could be real or imaginary. Distinct or repeated, or any combination. So real and distinct, real and repeated, imaginary distinct, imaginary repeated. So the solutions look different in the 4 cases. I think it's worth going over the cases separately, so I'm going to make one separate video for each of those cases. The end.